Hey YouTubers, what's going on? Daniel Dallas is right here, and I open new series for geometry, alright? So the starting point in geometry is Pythagoras theorem, alright? What is it all about? It's about a specific type of triangles. First of all, let's consider the idea of what triangles is, what kind of shape, and then we'll switch to specific triangle. Alright, so there are three elements in the triangle: three sides, three angles, and three vertices. Alright, so that's why, first of all, let's give a definition of what triangle is. Triangle is an enclosed shape with three sides, three angles, and three vertices. Alright, so sides there, we mark them if they're all different with specific marks. They are all different. Okay, here's 1 mark, 2 marks, and 3 marks. It means all three sides are different. Okay, so angles we mark as arcs, and of course different number of arcs tells you about different measures for each angle. Okay, and vertices, basically they're points A, B, and C. Alright, so what type of triangle might be here? First of all, if we categorize them by side, they might be equilateral triangle, so equilateral triangle. Okay, so I denote this like small delta as a triangle in geometry. Remember, before in algebra we already used this symbol and it means delta. However, here we mark as a triangle. Okay, so equilateral, all three sides equal. Okay, we mark them with one single mark that denotes all three sides equal. Okay, so the second one, isosceles. Okay, iso means iso, not like isosceles. Okay, it means stays equal no matter where you at. So for example, isosceles triangle, isosceles triangle should have two sides equal. Okay, for example, like that. So two sides are equal, and that's like the last sides. Okay, we have specific properties about isosceles, but we don't touch them. We just categorize. And scalene. So the first triangle that was here is actually scalene. What does it mean, scalene? All sides different. Okay, it means no equal sides. Okay. And by angles, can we categorize? Yeah, of course. There might be acute triangles if all three angles less than 90 degrees. But here I want to highlight and put a stress on a right triangle. Okay, this is the candidate for right angle triangle. Why? Because one angle is 90 degrees. So we denote this with a small square. That means this angle C is the right angle. So we can write A, C, B. So C in the middle, that denotes actually what we have C as the vertex of the angle. Or sometimes we might use this, that means the same. So angle ACB is 90 degrees in both cases. Alright, so what can you say about, first of all, right angle triangle? If we know one angle, let's say 30 degrees, we can figure out another angle with no trouble. So this angle is actually beta, and we know that the sum of all three angles, including 90 degrees, including our right angle, should give us 180. Okay, so from here, with no problem, we can figure out B value. So for ABC triangle, if it's right angle, we can figure out the other angle if we're given one of them. Okay, so from here we can figure out beta is basically 90 minus alpha. That means 90 minus 30 degrees. Okay, so we know that there are three elements, but for our Pythagoras theorem, we don't require any angles at all, except for we need to know where right angle. Okay, so right now we're trying to figure out specific like terms that we will use to denote legs. Okay, to denote sides. Okay, you heard the first term, legs, and the one of them also that's very significant is hypotenuse, all right? So hypotenuse is the longest side that is opposed to the 90 degrees angle, okay? So we don't those angles at all for Pythagoras purposes. We just need to have only understand where is 90 degrees angle, okay? So let's denote the longest side that is always opposed to 90 degrees. It's here. It's opposed to 90 degrees. Let's denote as hyp. From the word hypotenuse, all right? Hypotenuse. Okay, that's the longest side. So shortly, it's just hyp. And we have two other sides. We don't care about how we mark them. We can mark like A and say B. And for hypotenuse, you always can see this letter C. That's normally the case. But we actually call them legs, right? So legs. It means they are not so significant as hypotenuse. Okay, so we know that hypotenuse should be longest side. So in the problems, we're not like able to define where a right angle is. So just pay attention to the longest side if you're given the longest side. So that's why the opposed to this hypotenuse should be 90 degrees angle is here. If vice versa, you're given 90 degrees angle, just make sure you understand that hypotenuse is the longest side opposed to this angle, okay? In our case is AB. All right, so actually, let's try to make a proof for Pythagoras. So let's do a little proof here, how we can obtain Pythagoras theorem, okay? So for this reason, just the only what we need to have a look is just a square, all right? Let's say that we have a square that is here, like long side square. Okay, so let's assume this is a square. It's not like so precisely, but anyway, you understand that it's square. Okay, 90 degrees angle here everywhere actually. So that the sum of all angles is 360. Okay, so let's say we choose the random points, for example here, and for example we know that this point is split your sides on two parts, let's say A and B, okay? So let's denote this like that and like this. So actually this point, this red point is split this side on two parts, A and B, okay? So we choose the same ratio, I mean A to B, on this side. So actually on this side and on this side, so that we will have a square that turned, okay? We basically know, because the ratio actually the same everywhere, so we will have one more square that is sort of inscribed into the bigger square. So this small red square is inscribed into the big one, all right? And let's mark the sides, okay? So this is B also, and this is A. So this is B again. This is A. This is B, and this A. All right, so looks like we have 4 right angle triangles. So actually, I highlight them. It's here. This is the first one. So this is the second one, and third and fourth. All right. So obviously, all triangles the same, because if you have a look at sides, they're all the same. And we mark also the square that is inside. Let's say it has sides C. So each side of the square is C. Okay, what are we going to prove actually in what actually Pythagoras theorem is all about. Pythagoras theorem states the following: all three sides of the triangle is actually, they are all connected with the use of one equation. So the longest side, no matter which right angle triangle you'll take, the longest side, c squared, basically it's hyp squared, equals to sum of the squares of two legs. So if we mark A and B corresponding legs, so we will have the following equation. Okay, so c squared, the longest side, is a squared plus b squared. Now it's time to prove. So actually, if we consider similar triangles marked as yellow, we need to prove that c squared will be equal to a squared plus b squared. Okay, let's try to do. So what you can do, actually, you can figure out the area of, let's say, complete square, this big one, which has the side a plus b, and we can figure out the area of this square through the areas of four right angle triangles and area of this inscribed red square. All right, so let's try to write this equality. So area of the big square is actually four areas of the small right angle triangles and the area of the small square. Okay, so I just use letters and indices to indicate this statement, and that's fair, right? The whole part is always, so it's always the sum or the sum or combination of smaller parts which it consists of. All right, so let's calculate the area of the big square. It's just simply a plus b, one side times the same side, because all sides are equal, so we can say it's a plus b squared, right? Okay, and it also equals to 4 times an area of a triangle. Let's calculate the area of triangle, but first we express it. So area of each triangle, b, let's say it's a height, while a is the base, right? So we know that for this reason, we can say that area of triangle is 1/2 height b times a, the base. Okay, so that's why we can write like this, 1/2 ba. Okay, and what about area of the square, of small square, that is red one, I mean with red sides. So each side is c, so we just need to add c squared. Okay, that's what we have. All right, let's do it. So now the only thing that we need to do is just to simplify. Okay, so here a plus b, you can use either the formula algebraic rule, right? A squared plus 2ab plus b squared. For those who don't know that, actually they can just simply multiply two identical brackets. So let's do it. A times a times b. So we have a squared plus ab, and then we'll do the same for b. So ba, this is actually ab, and b squared. So ab and b squared. So actually, if we simplify that, we'll have 2ab, and we reach this formula. Okay. So actually, by the way, I proved the expansion of the square. All right. So we know that I raised this for the reason to have enough space. Okay. And what we can do, we can simplify that. All right. So we have on the left side a squared, 2ab, and b squared. And here we simplify 4 and 2 cancel. We'll get 2ab and plus c squared. All right, so 2ab and 2ab can be cancelled. So where we arrive to? We arrive to a squared plus b squared is c squared. So actually, this is Pythagoras theorem. All right, so that's the end the end of proof, okay? So we proved Pythagoras. Okay, now let's consider first like simple problem and then go to more complicated. Okay, so for example, we have a right angle triangle. So with the sides, say 3, 2, and x. So units of length. We don't care about the units in this case. So find x basically. All right, that's the first problem. How to find x? Simply use Pythagoras theorem, and that's it. So x squared is 9 plus 4, so we'll get 13, and x is simply square root of 13. Of course, so actually you should write plus minus square root of 13, but you understand that side is always positive value, right? Because the length is positive in this case. So we erase negative and simply we stay with the answer. All right, that was simple. What if we actually given, let's say, we're given a triangle, right angle triangle, but we have, say, this side x, this side 3, and this side, let's say, okay, let it be 5. How to figure out x? First of all, write Pythagoras. Don't try to figure out x immediately. So first, normally write Pythagoras theorem. So equation starts off from the longest side. It's always the case. Okay, and from here, you can easily figure out x is square root of 25 minus 9. Okay, so we'll get 25 minus 9, well, actually square root of 16, and x is 4. All right, so this x is 4 actually. Okay, that's sort of like easy task, right? What if you're given, instead, let's consider a new problem. What if you're given a right angle triangle and now the side actually given as, let's say, square root of 10, for example, and here is square root of 2, and you need to find x. Okay, no problem. Just make sure you can work with surds. So what do you need to write? You need to write Pythagoras. How we actually raise the square root in the power of 2? What we need to do? Simply, there are like two ways. You can memorize that it's always under root expression. So in this case it's 10, in this case it's 2. So you just simply get rid of square roots. Okay, and the result is 12. However, there is like the proof, because normally if you work or used to work with indices, you know that square root of a is a to the power of 1 over 2. And let's imagine you square it up, okay? What happens? According to index rule, we need to multiply powers. 1 over 2 times 2. So what we'll get? 2 and 2 will be cancelled, and we'll get a to the power of 1, that's a. Okay, that's the same as if we just get rid of root and leave under root expression. Okay, so no problem, no problem. From here we can figure out x is square root of 12. Okay, once you got this answer, and you need to give the simplest form, or the form like a square root of b. In this case, there is the chance to simplify again. It's about how you can work with surds. Okay, we can simply say that 12 is 3 times 4, and we're saying that square root of 3 times square root of 4, which is this, is actually 2, right? While square root of 3 is third. So we'll leave as 2 square root of 3. Okay, that's the final answer. So those problems are not so complicated. However, you might find the following task. Let's consider problem 4 type. So let's say we have one triangle, which is like that. Okay, we have this, and let's say we have two sides equal. Drawn not to scale. Okay, so drawn not to scale. It means you don't need to look at their like sizes, how they correspond to each other, but look at basically marks. So pay attention, if you have two equal marks, means two sides are equal, okay? So don't worry, but that's not the end. We have, let's say, known value, 3, we have unknown value, hypotenuse, and we have another right angle triangle. For example, something like this that goes this way, all right? So this angle is 90 degrees, this angle is 90 degrees. Okay, if they mark like 90, okay, that's good. Even if it's drawn not to scale, you know that angle is 90 degrees. However, if just you see that it looks like 90 degrees, don't believe, because you mark not drawn to scale, okay? So, and what we have here, so we have side of, let's say 5, and we have another known, let's say x centimeters. So some units, okay, maybe centimeters, units of length. So what do you need to do? Find unknowns like x and y. Okay, so no problem. We have the first triangle, okay? We can figure out y, just simply write it, because this side is also 3. We can write Pythagoras, okay? According to Pythagoras, y squared is 3 squared plus 3 squared. So y squared is actually 18, right? So y is square root of 18, or because 18 is 2 times 9, if we figure out square root of, we'll get 3 square root of 2. Just again, see the topic, how to work with indices. All right, so the next triangle, I erase this one, so because we use that, and I mark now the triangle is here. All right, so there you need to find x. Once you found y, that's not the problem. Now let's find x. So x squared, it's hype, again opposed to 90 degrees angle. So we'll have y squared, I just marked as 18 and I plug this number. I don't want to go to cope with y because I need square, so I work directly with 18. And plus 5 squared, which is 25. This side is 5, okay? So we'll get the following. So x is square root of 35 and 8, 43. So we'll get 43 square root of it. Okay, we found all the sides. You see that actually just apply consistent application of Pythagoras. Okay, what might be the problem? Let's see like two nested triangle, for example, like this. So this word problem, not word, okay, word problem, geometrical problem. 5. So let's say we have a triangle, right angle triangle. Oops, let's do it like more proper. Okay, so this is right angle triangle. And let's say we have the median. So remember what median is? Is the line within a triangle that splits opposite side on two equal parts. So this is actually median, okay? That's median. You heard the term in statistics, right? Median, it also splits the set of numbers in two equal parts by 50%. So here in geometry, it splits the opposite side on two equal parts, okay? We know the two equal parts, that the side is split up by two equal parts. We don't know the value, okay? But we are given, let's say 4 and probably, okay, 9, all right? So what we need to do, find the length of the median, okay? So find the length of the median. Okay, if we mark like, let's say AB, that's going to be median. Okay, so how to work it out? If you start working, let's say median is AB unknown x. I put the value x here, okay? So immediately before like thinking, oh, I don't know, let's say, let's mark vertices like K, M, okay? Let's say you don't know this leg, BM, okay? However, you might use this triangle ABM as a right angle. Okay, so don't worry. Just first of all, in order to solve any task similar to it, like in just not in one step, you need to input some variables, okay? This part is going to be y. So this part is also y, right? So how to write Pythagoras theorem? Obviously, using triangle ABM, we can write the following. So x squared, the hype, right, opposed to 90 degrees angle in this triangle, it will be equal to y squared and plus 4 squared. Okay, don't worry that you have two variables. So you'll probably find it if you just keep going, all right? Now, I will use the big one triangle, I mean the whole triangle. So from triangle AMK, so the big one, right? Can we write the same Pythagoras? Yeah, of course. Sure, no problem. Because we know 9 as hypotenuse, right? 9 squared equals 2. It's 4 squared. And here's, be careful, 2y, right? So the whole length of this leg is 2y. So simply add 2y squared. So I use the brackets to say that 2y is everything is squared. So let's simplify. 8 to 1 equals 16 plus 4y squared. Okay? So in order to find our final goal is to find median. So median in our case is x, and you can see that median is here. All right. So in order to find median, we need to know y. To know y, we can figure out it from here. I don't need the square root of y because I have y squared, so just simply find y squared. In order to find y squared, 16 transfer here, and we divide by 4, by the coefficient, right? So we know that y squared is, so 81 minus 10, 71, and minus 6, 65 over 4. I don't want to cancel, just leave as it is. So where to put this y? Just right here, the way back, in order to find x. Okay, so I just rewrite this equation here. X squared is, so let's figure out what x squared is y squared, that which is 65 over 4, and we need to add 6, so 4 squared is 16. Okay, now we got the answer. So the common denominator is 4. 65 plus 4 times 16 is 64. And finally, we'll get 129 over 4. Okay, in order to evaluate square root, we just simply say it's square root of 129 over 4, which is square root of 129 over 2. Okay, that's it. And we actually done almost the whole stuff. However, I just want to pay attention to one more thing. What if you're given, let's say, maybe, okay, for example, let's consider this one interesting problem. That's going to be the last one. Okay, so problem 6. So we have the following. We have the line, and we have two perpendicular lines. Let's say one, and let's say another one. Let's be shorter. For example, this is 5. Let's say this is maybe 4. Let's say this is 2. All right. So we have like several segments. Let's mark them A, B, C, and D. Okay, just you need to find the distance from point A to point D. Okay, so distance from A to D. All right, in order to find the distance, I marked that here as the distance, the shortest route, right, from A to D. I mark as AD, and I also mark as unknown, okay? Let's say this red line, I mark as X. No, so actually it's distance, so we'll use the letter that makes more sense. So D, distance, okay? I mark this as D. All right, so we need to find D. Okay, this red segment is D. How to figure out? Okay, so we know that, actually, sorry, I forgot to mention that angle B and angle C, right angles, okay? So now, how we can apply Pythagoras theorem to that? Before we apply it, we need to figure out how to get the whole distance AD. Yeah, so probably what we can do, actually, the simplest way to do that is to draw up a new right angle triangle. So I'll use blue lines to show that. And what if you just take segment AB from here and transfer it to there, okay? So that we have the same length. So actually, B goes to C point and A goes here, all right? I mark as A star and B star. Okay, we transferred this segment. And we actually need to transfer the whole part down, okay? So, I mean, this is actually B star, B goes here, and C star is here. So actually, what we have this big right angle triangle. Okay, now we need to just simply to mark two legs, because the distance in this case, it's a height, right? This is height. Here, I mean, this red line, or it equals to distance. Okay, so we know that this angle is right angle. How to figure out D? We need to know like the full length of legs. So the bottom leg is actually 5, right? And 4, because we transfer AB segment here, so this is 4. So the whole length basically 6. So if I redraw what we have, it will be 5 and 6, and D is hypotenuse. Okay, now it's much easier, right? So we can figure out D as D squared equals 6 squared plus 5 squared. And it turns out to be 36 plus 25. So actually it becomes square root of 61. Okay, so that was the last word problem that I wanted to consider. And it was dedicated completely to Pythagoras and basically ability to think and transfer parts so that you will arrange a new shape. Okay, so one more time, like useful tips in the end. First of all, try to meet right angle triangle. Try to find it if it's not like so obvious, like in this case. So if you understand that you cannot see that, try to analyze angles. Maybe they will tell you that one of the angle is right angle. In this case, you'll have right angle triangle. So actually make sure that you understand where hype. Okay, in this case it was here, and it's always opposed to 90 degrees angle. Okay, and the last thing, how to use Pythagoras, just always, if we just go back, just always write this rule. So the rule that connects the long side hypotenuse with two legs. And even if you have a unknown one leg, don't hurry up. Just first write equation and later on try to express your unknown variable and make it as the subject. Okay, that was useful tips as well. Okay, so it was useful tips for you guys. Make sure you understand how it works, and of course It's about practicing. Just don't be lazy. Just keep practicing and you will beat your score. All right. Thank you and see you in next videos.